There are rare moments in human history when the cosmos reveals something so strange, so otherworldly, that our understanding of reality itself begins to shift. In October 2017, such a moment arrived, quietly, unexpectedly, above the volcanic peaks of Hawaii. Astronomers at the Pan-STARRS telescope spotted a faint object streaking through the sky at impossible speed. It wasn't orbiting the sun like a planet or a comet. It was slicing through our solar system on a hyperbolic path, meaning it came from somewhere else entirely. They called it Oumuamua. In the native Hawaiian language, the word means, a messenger from afar who arrives first. The name was fitting and haunting. For this object behaved like nothing we had ever seen before. It was fast. Too fast for anything bound by our star's gravity. Racing through space at over 87 kilometers per second, it had already passed its closest point to the sun by the time we noticed it. It was leaving, forever. Scientists rushed to track its path, but it was moving swiftly into the void. And the more we looked, the stranger it became. It had no comet-like tail. No plume of gas, no cloud of dust. And yet, it accelerated, gently but measurably, as it left the inner solar system. An invisible force seemed to be pushing it. But no one could say what that force was. Its brightness changed dramatically every few hours, suggesting it was spinning and shaped long and thin, or possibly flat and wide. Some described it as cigar-shaped. Others as disc-like, like a cosmic pancake. Whatever its shape, it didn't match any natural object we had ever observed. Theories multiplied. Some proposed it was a fragment from a shattered exoplanet. Others speculated it was a type of icy body we had never encountered before. But none of the explanations fit the full range of its bizarre behavior. Then came a bold idea, from a Harvard astrophysicist named Avi Loeb. What if it wasn't a rock at all? What if Oumuamua was something artificial? A relic of alien engineering? A discarded probe, or a light sail, drifting silently through the galaxy? Avi Loeb suggested that its unexplained acceleration might be due to sunlight pushing on a thin, ultra-light surface, something designed, not formed. The idea ignited debate and controversy. Many scientists rejected the notion outright, insisting there had to be a natural explanation. But even they admitted, Oumuamua was unlike anything we'd seen before. And then, it was gone. Too small to follow, too fast to chase. It vanished into deep space, beyond the reach of any telescope. We were left with questions and models, but no answers. In 2019, a second interstellar object was found, Borisov. It behaved like a normal comet, with a tail, gas, and ice. It was clearly natural. But Borisov only deepened the mystery of Oumuamua. Why did one act like a comet, and the other like nothing at all? Breakthrough Listen, a project scanning the skies for alien signals, pointed their instruments at Oumuamua as it passed. They heard nothing. No beacons, no radio bursts. No whispers. But silence does not mean absence. It only means we don't yet understand what to listen for. What if Oumuamua was a scout, drifting between stars for eons? What if it was searching, recording, watching? What if it was the first of many? Across our galaxy, there are hundreds of billions of stars. If even a small fraction host intelligent life, the odds of artifacts adrift in space rise dramatically. Oumuamua may have been one such artifact. Or it may have been a unique natural object, shaped by forces we do not yet comprehend. Either way, it changed the way we see the universe. It reminded us that years passed, but the questions lingered, unanswered, echoing in observatories and minds around the world. Oumuamua had come and gone like a whisper in the night. But its silence spoke volumes. It forced astronomers to rethink what space could contain. If one interstellar object could enter our system, how many others had passed unnoticed? How many had come in the dark, invisible, unrecorded? A quiet revolution began. New telescopes were proposed. New missions were dreamed. And one idea, bold and daunting, started to take shape. What if we could intercept the next one? What if, instead of watching it vanish, we could follow it? Touch it. Study it. Unlock its secrets firsthand. Enter the Interstellar Probe Initiative. A concept born from the questions Oumuamua left behind. Engineers imagined a spacecraft, waiting on the edge of the solar system. Fast, agile, built to launch the moment another visitor appeared. Its purpose? To chase down an object like Oumuamua before it vanished into the void. To catch the messenger, and read the message. At the same time, astronomers turned their eyes outward. They scanned the skies not just for light, but for shadows, anomalies, strange curves in starlight that might betray a hidden traveler. Some focused on unusual light curves. Objects that dimmed a star in unexpected ways. Was that a natural rock, or something else? Others looked for signs of controlled motion. A drift that defied gravity alone. And then came something extraordinary. From the Vera Rubin Observatory in Chile, an alert. A new object, faint, fast, incoming. Its trajectory, interstellar. Its speed, nearly identical to Oumuamua's. This time, we were ready. Within weeks, telescopes around the world locked onto it. The James Webb Space Telescope turned its mirror toward the object. And what it saw deepened the mystery. The object was tumbling irregularly, reflecting sunlight in sharp pulses, as if its surface was metallic. It had no gas, no dust, no thermal signature. But it was accelerating. Again. Just like Oumuamua. The patterns didn't match any known comet or asteroid. And then, for a brief moment, it blinked. A sharp pulse in the infrared spectrum. Too narrow, too focused, too clean. It wasn't natural. It was a signal. But it lasted less than a second. Some said it was noise. A sensor glitch. Others weren't so sure. At SETI, analysts replayed the data, filtering the noise, enhancing the waveform. They found structure, mathematical precision. Not random, not accidental. It resembled a repeating prime number sequence. The kind humans used to say, "We are intelligent, but it didn't come from us." This was not a broadcast. It was a pulse. A flash. A moment of intention. And then, nothing. Silence again. But this time, the silence meant something else. It meant we had been noticed. And perhaps, acknowledged. The new object, dubbed Oumuamua 2, passed closest to Earth within 0.2 astronomical units, closer than Venus. We watched as it curved past the Sun. Then, just like its predecessor, it began to fade. But we had seen enough. We knew what to look for now. The universe wasn't empty. It was watching. The age of passive observation was over. The age of contact had begun. Scientists began preparing a list: frequencies, pulse codes, geometric messages. If another blink came, we would reply. Not with words, not with radio chatter, but with mathematics. With symmetry. With light. Humanity was waking up to a greater neighborhood. Oumuamua had opened the door. Oumuamua 2 had stepped through it. The next one might knock. Or land. Or speak. And when it does, we must be ready.